हेलो फ्रेंड्स, हाउ आर यू। आप लोग कैसे हैं? मैं उम्मीद कर रहा हूँ आप लोग सब अच्छा। इन माय लास्ट वीडियो आई एक्सप्लेन द डिफरेंस between direct current, alternate current, what is instantaneous alternating current, and also regarding average current। आज का वीडियो कुछ टर्म्स का बारे में, जो टर्म्स अल्टरनेटिंग करंट के साथ जुड़ा है। सम टर्म्स एसोसिएटेड और कनेक्टेड विद अल्टरनेटिंग करंट, वो टॉपिक का बेसिक कंसेप्ट है, फंडामेंटल्स है, उसको समझना 100% जरूरत है। इसीलिए बच्चे, आई एम गोइंग टू एक्सप्लेन some of the important terms related with the alternating current. First term, today's concept is terms related with the AC current. I hope that you might have subscribed my channel. If you have not done, you do it as early possible. At the same time, don't forget to share this video with your friends. Let us start. First term is the maximum or peak value or amplitude of alternating current. So, what is the maximum, or we say that is the peak value, or we say amplitude of current. In fact, it is the maximum value of AC. I can write the maximum value of AC, alternating current, in either direction. In either direction means, let us see. This is the graphical representation of alternating current. See here. Here, the angular displacement is pi by 2, means 90 degree. Here the angular displacement is pi. Here the angular displacement is 3 pi by 2 by 270 degree. Here the angular displacement is 2 pi, that is 360 degree. You see that I have written maximum value of AC in either direction. वो पॉजिटिव डायरेक्शन में हो सकते हैं, वो नेगेटिव डायरेक्शन में हो सकते हैं. It comes twice. You see, एक बार वो पॉजिटिव डायरेक्शन में मैक्सिमम वैल्यू होते हैं, एक बार वो नेगेटिव डायरेक्शन में भी मैक्सिमम वैल्यू होते हैं. So, peak value in the sense maximum value. मैक्सिमम वैल्यू कब आते हैं? एक बार वो पॉजिटिव डायरेक्शन में आते हैं, एक बार वो नेगेटिव डायरेक्शन में आते हैं. That means when if the angular displacement is pi by 2, it attain its maximum value. और दोबारा जब angular displacement 270 डिग्री और 3 pi by 2 और डिफरेंट डायरेक्शन में, अपोजिट डायरेक्शन में, वो भी मैक्सिमम वैल्यू अटेन करता है. मैक्सिमम वैल्यू विद इन वन साइकिल comes twice, once positive side, once negative side. So the peak value, or we say amplitude, you see that you have studied earlier classes, the maximum displacement from the mean position, that is the amplitude. I used to represent it by I naught. So I can say that the instantaneous current I is equal to I naught sin omega t. I discussed it in my previous video, no doubt. Here what I am saying, when it attained the maximum value, it attained the maximum value when pi by 2, the angular displacement. That means in this case, if I use this is equal to I naught sine, in place of omega t, this line represents the angular displacement of omega t. Okay, so this is sine omega t means sine pi by 2. साइन का मैक्सिमम वैल्यू क्या है? साइन टेबल पे मैक्सिमम वैल्यू 1 when angle is 90 degree or pi by 2 radians I have taken. Okay, that means this is equal to I naught. Okay, suppose if this Wt is equal to pi, that means I is equal to I naught sine omega t sine pi. Okay, clear? So in that case it will be equal to 0. That means minimum. Here is the minimum, here is the maximum. I hope that you might have understood the term peak value or maximum value. It is the maximum value acted by an AC in either direction, either that side or this side. This is about the maximum or peak value. Let us go to the second important term, that is the time period. Time period, very very important concept. Time period. टाइम पीरियड का मतलब क्या है? एक साइकिल कंप्लीट करने के लिए अल्टरनेटिंग क्वांटिटी को, अल्टरनेटिंग करंट को कितना टाइम लगते हैं? द टाइम टेकन बाय एन AC to complete one cycle. The time taken by an AC to complete one cycle. वन साइकिल कंप्लीट करने के लिए जितना टाइम जरूरत है उसको टाइम पीरियड बोलते हैं. I can say the same thing in another way. What is time period? It is the time interval after which an alternating current gets repeated. Let us see. It is the time interval after which an instantaneous AC gets repeated. That means that is both in magnitude and direction. Listen carefully. It is the time interval after which an instantaneous AC gets repeated. Whenever I am saying about the alternating current, you can think about the alternate EMF, alternating voltage, all things are here acceptable. Okay? So it is the time interval after which an instantaneous alternating current gets repeated both in magnitude and direction. Let us see. This is the alternating current. Okay, you see that certain time it is getting repeat. So I said that time period means it is the time interval after which an AC gets repeated both its magnitude and direction. So I can say that here it is repeating after here to here is the pi, here to here is another pi, that means 2 pi displacement, this is the t, here is the 2t. How it is repeating, you see that. So simply I can write time period is the angular displacement by velocity. So I can write that t is equal to 2 pi by omega. That means time period is the ratio between angular displacement to the angular velocity. But here I have written the definition, time interval at which an instantaneous alternating current gets repeated. Just I want to justify it. See here. Let I be the instantaneous current. Let I be the instantaneous current at time t. Then how I shall write it? I equal to I naught sin omega t. This is the function or equation of the general equation of the alternate current. But AC I have mentioned I naught sin omega t. If omega t is the angular displacement. Suppose let I dash be the current after t, which is equal to 2 pi by omega. Okay, t means I have mentioned that is 2 pi by omega. Now this is the current at the time t. Then what will be the current after time t? Means 2 pi by omega. So I can write this is I dash by 5 is equal to I naught sin omega. In place of a small t, I am using t plus 2t plus capital T, or I can write I naught sin t plus 2 pi by omega. Okay, in place of capital T, I have used 2 pi by omega. That is the time period. Then here I left the omega. See here. Then what it will be? It will be equal to I naught sin omega t plus 2 pi. So we know that sin 2 pi plus omega t, that is equal to sin omega t. This is equal to, or I can write sin 2 pi plus omega t is equal to I naught sin omega t, because we know that sin 360 degree plus theta is equal to sin theta. So this is equal to I naught sin omega t. This is equal to I. That means I proved that I prime is also equal to I. That means time is repeated after regular intervals. It is the time interval after which an instantaneous AC gets repeated. Sorry, time not repeated. That is the alternating current gets repeat both in its magnitude as well as direction. Once again I am saying, It is the time interval, it is the gap after which an instantaneous AC, instantaneous alternating current or alternating quantity, it may be current, it may be voltage, it may be EMF, doesn't matter, gets repeated both in its magnitude as well as direction. Clear? Before that I said about the peak value or maximum value. When we say about the maximum value, that value is constant. That value depends upon the EMF and position. Okay? But here, this is the fact which gets repeated. So this is about the time period. Next term associated with alternating current, that is very important also. All these terms are equally important. What is that cycle? Cycle. So first one I said peak value, second one I said time period, third one cycle of an AC. Cycle of alternating current. What is that cycle? This is the variation of current. You see here. Here to here is one cycle. So I can say that the variation of current between two consecutive the variation of current between two consecutive similar instantaneous current, or I can say the variation of current between two consecutive instantaneous current of same magnitude and direction. We can say also like this: the variation of current between two consecutive instantaneous current of same magnitude and direction, that is one cycle. Here to here, this is one cycle. One wave completing here. Within one cycle, there will be two peak value. One is plus side, one is minus side. This is about the cycle of AC. This is the positive cycle, this is the negative cycle. So the fourth important point is frequency. Frequency means the number of cycles frequency, the number of cycles completed in 1 second or number of cycles per second is called frequency. You know that in different scientific purposes we use different frequencies of AC. For example, in our domestic purposes, generally we use the AC whose frequency is 50 hertz. So the number of cycles per second, I can write that F is equal to 1 upon T. So frequency is inversely proportional to time period. In place of T हम लोग लिख सकते हैं 2 pi upon omega. Okay? Because in place of time period I have taken 2 pi by omega. 2 pi is the angular displacement, omega is the angular velocity, what I discussed earlier. Or we can write that this is equal to W by 2 pi, or I can write that omega is equal to 2 pi f. Omega is equal to 2 pi f. I said that so far as the frequency is concerned, its unit is the hertz. Okay, shortly we used to write Hz. So domestic AC, it is 50 hertz. That means within 1 second it travels 50 cycles. It completes 50 cycles. That means, see that this is here is 1 cycle. In 1 cycle it is changing its direction twice. Once here, once here. That means 50 hertz frequency if it is there, उसका मतलब है वो current 100 times उसका direction change कर रहे हैं. The current is changing its direction 100 times because in 1 cycle it is changing the direction twice. That means in 50 cycles it changes its direction 100 times. So I said that for domestic purposes we use 50 hertz frequency, and so far as communication is concerned we use millions of frequencies, not thousand. We use millions of frequencies in case of communication. So this is about the frequency. Next important point is the phase. Very, very important. I hope that you will watch this video from beginning to end. As a result, you will get a clear concept regarding the topic what I am teaching here. Let us see. Next important point is the phase. Very, very important. What is phase? Phase means, you see, first before saying the definition, let us see. This is an alternating current. Suppose one more current starts here, or you see that suppose one more current is here, but both the current attaining the maximum value at the same time. If they attain the maximum value at same time, we say that is in the same phase. If they attain the maximum value at different phase, we say they are in different phase. So here in this figure, both current, this is the maximum value for this AC, this is another alternate current, but both are attaining the maximum value at a time. You see that when the angular displacement is pi by 2, they are attaining their maximum value. I am not telling both are reaching here. The different amount of current, no doubt at all. Okay, the maximum value depends upon its what? Depends upon The EMF depends upon the EMF, depends upon the its position in the circuit, its impedance in the circuit. So I am not telling about the maximum value, I am telling about the same phase. Both are achieving the maximum value at one time, so we can say that is there in the same phase. Let us see. So what is this phase? Very important point I want to say. See, when a generating element rotates in a uniform magnetic field. See, generating element means a coil, generally coil. When a generating element generally a coil rotate in an uniform magnetic field. Uniform magnetic field. It creates alternating current. Very important, listen carefully. जब एक कॉइल यूनिफॉर्म मैग्नेटिक फील्ड में रोटेट करते हैं उसी वक्त पर जो करंट प्रोड्यूस होते हैं उसको हम लोग एसी करंट बोलते हैं. द करंट विच प्रोड्यूस व्हेन a generating element may be a coil rotate in an uniform magnetic field. उस वक्त पर जो करंट पैदा होते हैं उसको हम लोग अल्टरनेटिंग करंट कहते हैं. लेकिन व्हाट इज द फेज? सो फेज ऑफ एन अल्टरनेटिंग करंट इज द फेज ऑफ an AC is the angle turned by a generating element, means coil, element with certain instant of time. How much with respect to certain with respect to certain instant of time, how much angle it is completing, how much angle the coil is rotating with respect to certain instant of time, that time we say phase of an AC. Another way I shall try to say you. Let us see. इस कोशिश करो दूसरा तरीका से बोलने के लिए. The phase difference between two AC is the order in which both the AC reach its maximum value. Both reach its maximum value. Let us see. Suppose two currents are there. That function is I is equal to I naught sine omega t plus phi 1. Okay, generally we write I is equal to I naught sine omega t plus phi. This part we say the argument part. This argument part in a complex number, you know, two parts, one real part, one imaginary part. Here one is the modulus part, one is the argument part. This argument part of the sine function is called the phase of an AC. Listen carefully. This is one current. Suppose I prime, I have taken I naught sine omega t plus phi 2. Two current, instantaneous current I represented by two equations. Here this phi 2 minus phi 1, this is the phase difference. This is the phase differences between two alternating current. Suppose if phi 2 minus phi 1 is equal to 0, that means both alternating current are in same phase. Try to understand, this is the central part of the topic. The word phase is very important. So I am trying to explain in different way to make you 100% not to understand but to feel what is exactly the phase. So this is the general form. We can write I sine omega t plus phi. You may say that in my previous method I explained only I naught sine omega t, because in that case I consider there is no phase difference. Just I was considering only one alternating current. The term phase difference did not come. Or you can consider that the phase difference is 0. So in this case I have used omega t plus phi in place of phi 1, phi 2 for two different alternating current. So the argument part Wt plus phi, which is the phase. Okay. So this is the argument part. Argument part of the psi function is called phase. The argument part omega t plus phi is called the phase. He said that suppose I have mentioned two alternating current I1, I2. I have written here phi 1, phi 2. So the difference between the phi 2 and phi 1 is the phase difference. If this is 0, that means both AC are in same phase. I am trying to say same thing in different manner. See it. This is one AC. आज क्या हो रहा है? कुछ डायग्राम नहीं है. Okay. See here. Now, suppose one wave is here. One more wave I can draw it here also, no matter. See, this is the peak value of the first AC. This is the peak value of the second AC. Now, I am writing, this is suppose the A is equal to A naught sine omega t. A naught sine omega t. Here you see that here the displacement how much? Here this is pi by 2. And here the displacement, okay, here the displacement is 1 more pi. Okay, that means this is equal to pi. Suppose this one I am writing, this is the function of the equation is b. Then b equal to how much I shall write. Now let us see. Suppose this one is the a, this one is the b. So between a and b, which one is lagging? Which one is lagging? B is lagging. Don't think that B is front, A is back. No. A started. After starting of A, after the angular displacement, mention here, after an angular displacement of pi by 2, second alternating current started. That means I can say that B is lagging behind A. How much angle it is lagging behind A? That is pi by 2. So I can say that B equal to B naught sine omega t minus pi by 2. This is the phase difference. You see that here is pi by 2, here is pi. That means the difference is 90 degree. The difference is 90 degree. So this is A naught sine omega t. I have written B naught sine omega t minus pi by 2. This is about the phase difference. Similarly, if I start one more way from here, suppose this is minus pi by 2. Minus pi by 2. Here also it travels like that. It reaches its maximum value also at 0. That means after pi by 2. Okay. So this is about the phase. One more important term I shall use, that is the phasor diagram. Okay. So what is that phasor diagram? The diagram which shows the phase differences. A diagram which shows the phase differences between two alternating current. You see that now I mentioned earlier Ia is equal to A naught sine omega t. Suppose this is the angle all the time we should take it anti-clockwise. So this is the representation or rotation of a vector, you can say. This diagram is the rotation of a vector. From where starts? From lagging point. Between A and B, which one is the lagging? Which one is the behind? B was behind because A started after 90 degree, B started. So in this case, see that suppose this is the B. So B is equal to B naught sine omega t minus pi. Okay, this angle is omega t. This is A. This is A naught. A equal to A naught sine omega t. So this is just rotation of a vector from lagging point to forward point. Okay, here A is A naught sine omega t, but B is lagging from A by an angle of omega t, by an angle of pi by 2, 90 degree. That's why in place of omega t, I am writing it omega t minus pi by 2, sorry. Okay, minus pi by 2. Okay, so here B equal to B naught sine omega t minus pi by 2. Okay, so I hope that you might have understood the today's concept what I said, different terms associated with the alternating current. I explained about the cycle, I explained about the peak value, time period, frequency, phase and phase difference. So after sine what is written, that is only phase. It may be omega t plus 5, doesn't matter. What is written after sine function, that is the phase. So this is for today. Next video I shall explain some more new concept. Until then, bye.